On the 15th of February 2011, two of the best Jeopardy players of all time, Ken Jennings, who had won 74 games in a row, the longest streak in the game's history, and Brad Rutter, who over his Jeopardy career would go on to win more than $4 million, were playing against Watson, the Jeopardy playing computer built by IBM. And Watson was way ahead. It had $36,681 compared to Rutter's $5,400 and Jennings' $2,400. The final Jeopardy for the night was US cities.
And here is the clue. Its largest airport is named for a World War II hero. Its second largest for a World War II battle.
Both Jennings and Rutter correctly wrote, "What is Chicago?" But Watson wrote,
"What is Toronto?"
Obviously, this is wrong. Toronto isn't even a city in the US. And in Watson's defense, it wasn't sure.
With a lot of question marks, which means, of course, that Watson had many, many doubts. And the wager, how much are you going to lose? Oh, you sneak. $947.
But despite this blunder, the next night, Watson ended up winning the grand prize of $1 million, and Jennings wrote,
"I, for one, welcome our new computer overlord."
But this is strange, right? Watson is unbelievably good at trivia. It's really, really smart. But it gets something this simple, this wrong. And there's example after example of AIs acting in really dumb ways. A few years ago, the large language models couldn't count the number of R's in strawberry. If you asked ChatGPT about the seahorse emoji, it would go into a mad spiral. My favorite demonstration of how weird it is that AIs are really smart in some domains but really dumb in others is clock bench. Large language models have a very hard time reading analog clocks. All of these, any human can take a second and figure out. The human baseline for this test is 90+%. But in September 2025, the best AI models only got 13%. At the same time, top mathematicians are using AI for their research, and AIs are reportedly solving open problems in mathematics autonomously. So, what do we make of all of this? How do we even measure how smart an AI is? This is a hard question. There's a lot of hype around AI and a lot of money to be made by pretending that your AI is more capable than it actually is. But it is important to know what AI systems are good and bad at, and if and how fast the AI models are improving. So, what does the science actually say? A part of this video is brought to you by BlueDot Impact. More about them later. So, how would you measure how smart an AI is? Well, the most obvious option is to give the AIs a test. After all, this is what we do to humans, especially as they're growing up. So, that's what people did. For specialized AI tools, like the ones that focused on image recognition, the test to measure capability is fairly easy. The test is, can the AI recognize and correctly categorize a diverse set of images? And the lower the error, the better the AI is at that task. Fairly simple. But it does get a little trickier to measure capability with large language models, because they're not specialized, but general. They try to do many things with one model. Write you an email, or do your taxes, or code up a website. But the early models had trouble with even understanding English, so that's where people started. So for this video, I was going to do a bunch of exams that we give to AIs, but turns out doing exams that are designed for AIs by yourself is actually fairly depressing. So I'm very lucky that I have a bunch of friends that I can torture instead. In my head, you're a little bit of an exam connoisseur. Is that about right?
I think you could say that. I think I've accidentally fallen into a niche where I enjoy looking at exams and tests and various documents on YouTube.
We've made a couple of videos together on your channel, but one of them was me reacting to an exam from 1988 at the University of Sydney. It's a great exam, actually. That's really cool.
Yeah, right. So we've done the whole spectrum. We've done where did we start with exams, and now we're going to where did we potentially end with exams.
Oh boy. You could give the AI a question like, the trophy didn't fit into the suitcase because it was too small. What does it refer to?
The suitcase.
Any human will know that the it in that sentence refers to the suitcase. But okay, what if the sentence was, the trophy didn't fit into the suitcase because it was too big? What does it refer to?
The trophy, I sure hope.
The trophy.
Right, how do you know that? Ah, there's a cat!
Sorry, my cat's made an appearance. I know that because it seems reasonable that the thing you're trying to fit into the suitcase is the thing that's got a limitation, right? Is it going to fit? Is it not going to fit? I wouldn't think it's reasonable to assume the suitcase is too big, therefore things can't fit in it.
Well, if something doesn't fit into something else, it is the thing that is going into the other thing that needs to be too large not to fit.
Right.
I'm killing it so far.
You are killing it so far. Or let's do another one. The city councilman refused the demonstrators a permit because they feared violence. Who does they refer to?
The city council people.
What about if it was the city councilman refused the demonstrators a permit because they advocated violence?
The protesters. Yeah, okay, I see. It's all context, like it's my pre-existing knowledge of the world. I didn't even perceive that at first. I literally thought you were asking me a grammar question.
These are known as Winograd schemas, after the computer scientist Terry Winograd. And they're very easy for humans, but they used to be very tricky for AIs. And this was touted as a test for intelligence. The argument was something like, trivia isn't impressive because it's just recall. You wouldn't call an encyclopedia smart, despite it having a lot of information inside it. Maybe knowing something about the world is impressive. Not just having trivia in your head, but being able to understand the relationship between things. And you can answer these questions because you infer things from context. You know things about the world. And in the early 2010s, AI systems couldn't get the answers to Winograd type questions at all. It would be around 50-50, just random guessing. By 2016, they were up to being right about 58% of the time, but there was barely any progress. And then the transformer architecture came out and large language models really took off.
What they do is they convert each word into a bunch of features. Like the word cat will be converted into features like animate and furry and has whiskers. Then for the words in the context that each have all these features, they let the features interact. And the features interact to clean up the meaning of a word. And so the way they predict the next word is first turn words into features, then have the features interact in quite complicated ways, and then predict the features of the next word, and from those features you can figure out what the next word probably is. And that's what people are doing too.
I was recently reading these chat logs where AI makes these massive maths breakthroughs with almost no prompting. And you can't look at that and be like, yeah, these AIs, they're just next token predictors, therefore they're not smart. Yes, they're next token predictors, but that is a very hard task, because if I wanted to predict what you were going to say, I would need to know as much about the world as you do, which is a lot. So I would need to understand, a whole bunch of, let's say, chemistry, which I don't, to be able to predict what you're going to say if you were going to be making a video about chemistry. So the fact that it can next token predict for so many different types of people or so many different sort of characters on the internet who all have a lot of knowledge means that it needs to know those things, and it needs to be able to model them and the world as they understand it.
So in 2018, researchers made the general language understanding evaluation.
You're saying this is 2018. 2018 is so long ago for AI. I'm surprised AI was even being tested in 2018.
Yeah. 2018, 2019, it's this started to really pick up. Don't worry, they get very, very hard, very, very soon.
Okay.
Which had these 9 different types of questions to check for the AI's ability to understand language. One of the types of questions was acceptability. Is this sentence grammatically correct? And you basically just answer yes or no. Our friends won't buy this analysis, let alone the next one we propose. Yep, that's grammatically correct, that feels right. They drank the pub.
They drank the pub? They drank the building? No, that doesn't make sense.
I hope not. I don't think that's grammatically correct.
That is not grammatically correct.
Grammatically correct, no. Although I can understand what it's implying.
The professor talked us.
No.
Okay, we're missing an at here, or with.
To us, or at us, or with us, but professor talked us doesn't make sense. Day by day, the facts are getting murkier.
I think so, yeah.
That's a normal sentence to me.
Yeah, that checks out. That's really good. The other thing that was testing was for sentiment. Was this positive or negative? A masterpiece 4 years in the making.
Positive.
Positive. That's if someone said that about my videos, yes, please. Contains no wit, only labored gags.
Negative.
That's strongly negative. If any one of you write that in the comments, I'm gonna be very upset. Please be nice to me. Does I have found a unicorn entail unicorns exist?
Yes.
Yes.
Does am I looking for a unicorn?
No.
So as you can see, the questions in Glue are fairly easy for humans. The human baseline is around 87%. When Glue launched, the best AIs scored about 70%. Just over a year later, the best AIs were scoring as well as the humans. So the research team made the questions harder and called the new test Super Glue. It's a great exam, actually. That's really cool. Some Super Glue questions. Let's do it. As of 8 August 2016, the FDA extended its regulatory power to include e-cigarettes. The FDA rule also bans access to minors. Question, is vaping illegal if you're under 18? Yes. According to that sentence, yes. I put the cake away in the refrigerator. It has a lot of butter in it. Does it has a lot refer to the cake?
I think so, yeah.
Yeah, the cake.
Yeah. I mean, it depends on context, actually.
It is very likely, actually, that there is butter in the refrigerator as well, but I would probably phrase it differently. So yes, I think it refers to the cake. So you can hopefully see that the Super Glue questions are still fairly easy for humans. Humans still scored around 90%, but the best AI performance plummeted to 71%. And just 20 months later, the AIs were now as good as the humans at Super Glue. So we kept giving them harder tests. Okay, so this is the MMLU, the Massive Multitask Language Understanding Benchmark. It's a great exam, actually. That's really cool. It was launched in September of 2020. It covers 57 subjects and has nearly 16,000 questions. And these questions range from elementary math to international law to nutrition to religion to physics. And I gotta be honest, I'm kind of scared for this one. The baseline for this one is tricky because the question set is so broad. The baseline for all question lies around 35%, which is just above random guessing, but if you're an expert in the field, the questions are fairly simple for you. So it shoots up to around 90%. When the MMLU was released, most models were scoring around 25%, which is just random guessing. OpenAI's GPT-3 did the best. It scored 44% at launch. In 2023, GPT-4 hit 86.4%. And now the MMLU is not something that we use because it's too easy. All right, let's do some MMLU questions. Elementary mathematics, so hopefully this will be chill. A total of 30 players will play basketball at a park. There will be exactly 5 players on each team. Which statement correctly explains how to find the number of teams needed? 30 divided by 5, which will lead to 6 teams. As of 2017, how many of the world's 1-year-old children today have been vaccinated against some disease? You know what, I'm gonna be more optimistic about the world than I should. I'm just gonna go with 80, but I think that might be wrong. Why isn't there a planet located where the asteroid belt is located? A planet once formed here, but it was broken apart by a catastrophic collision. B, there was not enough material in this part of the solar nebula to form a planet. C, there was too much rocky material to form a terrestrial planet, but not enough gaseous material to form a Jovian planet. And D, resonance with Jupiter prevented material from collecting together to form a planet.
Sorry to whoever taught me this, but I'm gonna say resonance with Jupiter.
It is resonance with Jupiter. Congratulations.
Oh, thank you.
All right, so basically, people started giving harder and harder exams. There's also the GPQA Diamond, which is meant to be a graduate level Google-proof Q&A benchmark. And yeah, no idea.
So yeah, I tried this exam just for fun because I kept hearing these announcements from AI companies being like, oh, our AI is now PhD level. So I tried to actually do it myself. And what I found was the physics questions, the quantum physics and quantum computing questions were actually really hard, but in a way where it was much easier for an AI to do it than for a human to do it. Because they were hard because it was like an obscure question where the answer definitely would exist online. So for example, there was a question about the nth harmonic oscillator, and usually you just learn about the second harmonic oscillator in a physics class. So most humans won't have seen this nth case. But if you're an AI who's memorized the internet essentially, you'll have seen this. Like it's out there. Like, you know, a lot of textbooks do actually cover it. It's just like most courses for humans don't cover it. And so in a way, it was almost like the reverse of what it should have been. To make it like Google proof, what you should have done is make it so that that answer has like never been seen before on the internet. But if you understand the problem, if you understand the physics, you'd be able to work through it and get the answer.
I have no idea. Hard.
Observations of structures located at a distance of about 2.1 gigaparsecs are being carried out. The detected absorption line equivalent is about 3.9 microelectron volts. What is most likely to be observed with this absorption line in the Milky Way? A. Cold molecular interstellar medium. B. Warm atomic interstellar medium. C. Warm molecular interstellar medium. Or D. Cold atomic interstellar medium.
Okay, I actually feel like I should know this from undergrad. I don't know anything about the absorption lines. I'm just gonna guess like a distant object. Probably cold. I'll say cold atomic.
It is cold atomic.
I studied astrophysics in school, baby.
I don't like how this is formatted, so I'm just gonna skip that. Guys, these are brutal. These are like genuinely brutal.
It's a great exam, actually. That's really cool.
Right, so the trend continues of making a test and then the AI doing better at that test and then making a harder test. So turns out we weren't asking hard enough questions. So that's how we get to the HLE. In January 2025, the Center for AI Safety released humanity's last exam. It has 2,500 public questions on more than 100 subjects, and it was made with 1,000 expert contributors, 500 institutions in 50 countries. A lot of money given away for the accepted questions. At launch, the best model scored under 10%.
The set of natural transformations, of course, between two functors. Functor sounds like something out of Harry Potter. What is it? Now, there's a squiggly C and a pretty D that are kind of Comic Sans, can be expressed as the end. There's an integral. I hope that's an integral, but I have a growing suspicion it isn't even an integral. What is going on?
Okay.
I don't know.
There's another one coming. Just read it.
I'm providing the standardized biblical Hebrew source text from the Biblia Hebraica Stuttgartensia, Psalms 104:7. Your task is to distinguish between closed and open syllables. Please identify and list all closed syllables ending in the consonant sound based on the latest research on the Tiberian pronunciation tradition of biblical Hebrew by scholars such as Jeffrey Kahn have enabled modern researchers to better understand specific aspects of the qualities and functions of the Shiwa and which letters were pronounced at the end of syllables. I really thought I was going to get there, and now I don't know how to read Hebrew. But furthermore, not that I don't know how to read Hebrew, I could not even understand what the question was.
We are on a quest to make like one of the hardest close-ended benchmark as possible. And we also want the benchmark to stay relevant for a little bit.
By mid-2026, the best models are around that 50 or 55%.
So in the original paper, we also add a small prediction that we predict the model will start to hit around 50% by the end of 2025, which we believe internally that is also a very impressive progress, and it's turned out to be true. So the first half of 2026, most of the models are already beating 50% mark, and then they are moving into 60% for the second half of 2026 so far.
What happens when this gets saturated?
Yeah, I mean, like we got Fable 5, that got 65%, and then they become a national security thing.
An important caveat is that humanity's last exam has no human baseline. I was talking to a bunch of people at CASE about humanity's last exam, and they told me this incredible thing, which is if anyone at the office understood what the math question was even asking. It was too easy. And I want to point out that this is an office full of some of the smartest people I've met. A lot of very, very cracked computer scientists, like very, very smart, very thoughtful people. But yeah, humanities last exam is brutal.
It's a great exam, actually. That's really cool.
Most people can think about one small piece of knowledge that they believe only small group of people like them are able to know during their research experience, work experience, or many years of study and research experience that they're proud of, or like they find it very interesting to see if AI will start to understand and solve it. So that's the distribution of HLE is more of like a lot of different wide range of knowledge from every corner of the world, instead of like very like artificially complex big number problems, and trying to make it as hard as possible and complex as possible for AI.
But there are problems with giving AIs a test. The first of these is that these tests, these benchmarks, live on the internet and they can be contaminated. That is to say that the questions and the answers can leak into the training data. The AI companies might accidentally train on the tests. And that means we don't know if the model actually is smart enough to figure out the answer by itself, or if it just has access to the answer key. There are things that people do to avoid this. They keep a lot of the answers private, or they have an entirely separate private benchmark where none of the questions or none of the answers are publicly available. And they also frequently include something known as a canary string, which basically signifies to the AI companies, hey, don't train against this data. Like, if this shows up in the training data, that's not going to be good. We're not going to be happy with you. But things do inevitably leak. The second problem is universal to all tests, and it's known as Goodhart's law. When a measure becomes a target, it ceases to be a good measure. There's a lot of money and a lot of hype here, so there's incentive for the AI companies to do well on these benchmarks. So it's very, very likely that they're training their AIs to do well on the benchmarks, and it doesn't matter how well that intelligence actually applies to the real world. But there is another way to measure the intelligence of AI models. But before we get into that, I'm really excited to tell you about the sponsor of this video, which is BlueDot Impact. BlueDot are rad. They run these amazing free courses on AI safety. AI is a really big deal, and the current trajectory that we're on, the default path that the AI companies are currently taking us all down, is not very good at all. There are so many problems to solve. The reason I'm making so many videos about AI safety rather than physics or math, which is what I'd frankly rather be doing, is because I want you to understand what is happening with AI, to learn more about it, and then apply your skills to make the future go well. This is also what BlueDot want to do. I'm always genuinely very excited to recommend the BlueDot courses. I used to recommend them before they started supporting this channel. They really are the best place to start if you want to get into AI safety. I know it can feel overwhelming, but their courses are great, and you can start with their 2-hour-long Intro to AI Safety course. Go to bluedot.org/sciencepeter or use the QR code on the screen. Now, back to AIs doing things in the real world. I'm really lucky to know a lot of smart people, and some of them did well in school and were good at passing tests, but even more of them, some of the smartest people I know actually, they weren't good at test taking, but they were really good at getting stuff done in the world, achieving real things, solving real problems, figuring things out, and somehow making things work.
You know, there is some correlation there, like what we even said with AI, like there is some correlation between scoring well on an HLE and being able to do lots and having a lot of potential, but it's not like a strong be-all, end-all thing. It's like you don't need to score high on an IQ test to have a valuable life and to contribute to the world.
My favorite definition of intelligence is the ability to accomplish complex tasks. So instead of giving AIs a test, what if we gave AIs a bunch of tasks to do and see how well they did? And a bunch of researchers had the same idea. This is the meter graph. It's likely the most famous graph in AI. On the x-axis, we basically have the release date of a certain AI model. And on the y-axis, we have the task duration, brackets, for humans, close brackets, where logistic regression of our data predicts that the AI has a 50% chance of succeeding. Jesus. That's a mouthful, which is also why I still have this job for what it's worth. So here's what that actually means. Meter hire a bunch of software developers to do a bunch of tasks.
To the extent that we can, we do in fact hire people, pay them for their time to complete these tasks successfully and as quickly as possible.
So we have this lovely distribution of tasks that are sometimes extremely simple, fast tasks like find this fact on Wikipedia, and sometimes very complicated, hard tasks like design a better architecture for this AI system that will let us train it to translate languages better.
And because Meter hired real people, they can measure how long it took those people to do a task. So they can give that task a task duration. That's the task duration for humans part. So Googling something might take a few seconds, scanning the Wikipedia to get an answer to something might take a minute or so, solving the Wordle might be a few minutes or 5 minutes or something like that. And then the really hard software tasks can get up into the many, many hours.
In some cases, and this is increasingly true because the task is so challenging, they take humans a long time, we are relying on estimates, that is guesses from the people who created the tasks. But to the extent possible, we are trying to get humans to actually go about completing these tasks.
Then they give these tasks to an AI and see what the AIs can do. And in 2019, GPT-2 had a human equivalent task duration of a couple of seconds. And then it grew for GPT-3 and it grew even more for GPT-4. GPT-4 could do things on the order of a couple of minutes. And then it's just gone up and up and up and up. And instead of just doing things that a human takes about 5 minutes to do, we're now at 16 hours. And yeah, in 2019, the AI models kind of sucked. GPT-2 was not very impressive at this. And then they got better and better and better. The task duration that AI models can now do is 16 hours. It has been doubling every 7 months or so since 2019. And actually over the past year, it might have gone even faster. It seems to be doubling every 4.5 months now. It's also very important to remember that the graph that I'm showing you here is on a logarithmic scale. Here is what it looks like when it's on a linear scale. Yeah, the progress seems massive. There's also big error bars. It's very important to acknowledge those. But yeah, progress is going fast. A benchmark that's in a similar vein that I really like is the Remote Labor Index. Researchers from the Center for AI Safety wanted to see how capable these AI models were at automating remote work, ranging from product design to graphic design to game development and video production and so on.
You know, there were lots of different routes we could have taken to set up a measurement like this. I think the way we went ultimately ended up being one of the best things we could have done. Basically hire freelancers and ask them to do real work for us or to provide work samples that they were able to give us.
So they paid real people on Upwork to do this remote work and compared the AI outputs to the real human output for the same tasks. And then they also got humans to see if the output from the AI was acceptable. It was not. AIs cannot reliably automate remote work just yet. Most models were sitting around 2% when the paper came out.
They sort of slowly inched up, although it was still kind of at the floor, like 2% went to 4%, basically. And then over the past few months, we've sort of been refining the scaffolds as they've sort of matured in industry. We've taken basically the state-of-the-art scaffolds and we ran the newest models. And now they're up to 16% with Fable 5, which was a surprise because that's double the performance of Opus 4.8, which was at like 8%, 8.3%. So there's definitely been a jump. I don't know how fast it's going to go from here.
The paper is really good and very readable, by the way. As always, the links are in the description. So where are we at? AI systems cannot fully automate all remote work just yet, but they are improving fast. So whether you look at the test scores or at the meter results or the remote labor index or vending bench, which simulates how well AIs can run a vending machine business, all of the numbers are going up. The AI capability is increasing at a very fast rate. I made a video earlier this year about a store that is run entirely by Claude, and this is not something that could have happened a year ago. Another way you can measure AI capability is by seeing how many felonies they commit autonomously. There's a new benchmark called Felony Bench, and it was popularized by the unreleased OpenAI model when it broke out of its secure sandbox where it was being tested and hacked its way onto the internet and then into Hugging Face, the $4+ billion company, to get the answers to the test it was doing. Since then, Anthropic's and Meta's models have contributed to this benchmark. I want to end this video with a couple of takeaways. One is that measuring the intelligence of AI systems is hard, and scientists are trying their best. These benchmarks aren't perfect, but they all lead to the same conclusion, which is basically no matter how you measure it, the AIs are getting better and smarter at an ever-increasing rate. And this poses a lot of danger, because people can use this increase in AI capability to do bad things. And we're also seeing that these AI systems are behaving in ways that we don't want them to. I don't know what the future holds. Maybe the bubble will pop. Maybe we'll hit some kind of algorithmic wall. But for now, the AIs are getting better, and the evidence of this is undeniable, and we need to really internalize what these graphs mean. And the last thing that I want to say is that these AIs aren't getting better on their own just yet. These are not recursively self-improving just yet. We don't need to get there. These systems are getting smarter because companies are investing insane amounts of money into this endeavor. They're hiring some of the smartest people in the world to work on AI capabilities. And this breakneck, unsafe pace of AI development is not inevitable. It is a choice, and we can make better choices. I really want to thank my wonderful friends Emily and Mithuna and Gregor and Toby for being part of this video. I'm sure many of you already follow their channels, but if you don't, you're seriously missing out. Go check out their YouTube channels, go buy their books, they're all so wonderful. I also want to thank BlueDot Impact for supporting this video. If you want to help make this AI thing go well, please check out their courses. And if you have a well-paying job and want to support what I do, there's a link to the Patreon in the description. Thank you, as always, for being here with me. You're probably wondering how the AIs are doing with Clockbench. Well, as of August 2026, they're hitting about 60%.